The difference of two squares is really explained in the name. You need to know the name so that you know what you need to do. So it says the difference. Well, that's because if you're given a subtraction problem, so it has to be a subtraction problem, between two values that are perfect squares, we can factor this. So, for example, this is the general rule. A squared minus B squared factors into A plus B and A minus B. I know this general rule might be a little tricky for you to follow, so let me show you an example. Alright, say this was your polynomial, and the first thing you notice is the subtraction sign. Then the first term, right here, is a perfect square. Do you know what the square root of x squared is? Well, it's x. Taking the square root of something undoes taking something to the second power and vice versa. So if I said 4 squared, that's 16. But then if I take the square root of 16, that brings me back to 4. So, going back to our example, x squared is a perfect square and so is 4. Do you know the square root of 4? It's 2. Okay, so with this thought process in your head, all it is, when you factor, is x plus 2 and x minus 2. So my factored form is made up of this first term being square rooted and the second term being square rooted. Notice how I have x plus 2 and x minus 2. So another example, x squared minus 25. Well, what's the square root of x squared? It's x. What's the square root of 25? It's 5. So my two factors are x plus 5 and x minus 5. And that's it. I just want to make a note, for just so you know, it doesn't matter if you have the plus or the addition or the subtraction binomial first. So you could have also said x minus 5 times x plus 5, because remember, when you multiply, the order doesn't matter. Alright, let's try one more example and see if you can get it. X squared minus 36. Go ahead and try this example on your own and see if you get what I get. Okay, so the square root of x squared is x, and the square root of 36 is 6. So my factored form is x plus 6, x minus 6. And that's it. This, I would say, this is one of my favorite types of factoring because it's quick and easy. It's the same number, meaning this 6. It's the same number twice, but one's a plus and one's a minus. Before I give you a couple more problems that are a little bit more challenging, I need to point out that you need to have memorized all of your perfect squares. So let's go through them and see if you have them memorized. 1 squared is 1. 2 squared is 4. 3 squared is 9. Now see if you can go all the way up to 12. Alright, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, 12 squared is 144. in our class, you need to have these memorized. And the reason why is because you need to be able to recognize when there is a perfect square so that you know you can use the factoring method, the difference of two squares. Okay, I'm going to give you 3 problems on this next page, and they're a little bit harder, but I want you to pause the video and see if you get them correct. Okay, so this is the same process. You're going to take the square root of your first term, but we have this 4 in the way. Well, what is the square root of 4? Well, it's 2. And then what's the square root of x squared? It's x. So that's my first term. Then you have 9. So you have plus 3, because the square root of 9 is 3. And then you have 2x minus 3. For the next one, the square root of 9 is 3. The square root of x squared is x. And the square root of 49 is 7. 3x minus 7, 3x plus 7. And this last one down here should be 5x plus 10, and then you have 5x minus 10. Alright, try this next example. Last one. Does this factor? No, it does not. And I'll tell you why. Right here. So for the difference of two squares, you not only need the first and second term to be perfect squares, which they are, but you also need there to be a difference. So it has to be a subtraction sign. Okay, what if I gave you x squared minus 10? This is not factorable using the difference of two squares because 10 is not a perfect square. And then if I gave you x minus 100, again, it's not the difference of two squares because this is x. It's not x squared. It has to have a 2 here for us to be able to factor this.